In a pristine environment, ecosystems operate in a precise biological balance, but that balance shatters when industrial operations discharge their byproducts directly into shared habitats. We define this as anthropogenic pollution, the human-made disruption of the Earth's interconnected systems, distinct from natural events like volcanic eruptions or forest fires. When contaminants enter the environment from discrete, localized, and easily identifiable origins, like these factory smokestacks, it is classified as point source pollution. In contrast, non-point source pollution is scattered and diffuse. Think of agricultural runoff or urban street drainage. Because it lacks a single exit point, it is significantly harder to track and control. Historically, leaving these emissions unchecked led to lethal impacts on human health. Without a system to enforce limits, air quality in industrial hubs reached levels that drove massive spikes in respiratory disease and death. This dynamic illustrates the tragedy of the commons. It is an economic principle where individuals, acting in their own immediate self-interest, inevitably deplete and degrade the shared resources everyone depends on. Protecting public health requires more than voluntary goodwill. It demands a coercive system that establishes firm limits and mandates compliance to prevent the exhaustion of the commons. Malaysia's Environmental Quality Act of 1974 acts as this primary legislative framework, serving as the state's tool for environmental protection. The EQA categorizes its restrictions to target specific environmental vulnerabilities: air, noise, soil, inland waters, and scheduled wastes. This is an end-of-pipe regulatory approach. It grants the Director General the power to intervene, specify conditions for any discharge, and penalize those who violate established standards. The law also includes preventative requirements. Section 34A mandates that an environmental impact assessment report be approved before any high-impact project can even begin. This map shows how authorities track atmospheric pollution using real-world data. These monitoring systems are the backbone of enforcement. Without reliable data, emissions limits cannot be legally defended. While laws like the EQA are essential for triaging damage, they are inherently reactive. They manage the release of toxins rather than stopping their initial creation. As modern industrial production scales up globally, merely treating and disposing of waste becomes an unsustainable, unwinnable battle. To solve this, engineers use the waste management hierarchy to shift focus upstream. At the bottom is disposal, managing waste already generated. At the top is reduction, altering the process so hazardous waste is never created. This proactive strategy is known as pollution prevention, or P2. Tools like industrial waste auditing and source sink mapping allow engineers to identify system inefficiencies, enabling them to substitute hazardous substances with harmless alternatives before they ever enter the waste stream. Engineering out waste before it happens is the most effective way to protect the ecosystem, and it is consistently cheaper than paying for end-of-pipe treatment and legal penalties. There is a symbiosis between regulation and engineering. When strong laws force compliance, they drive industries to innovate, making pollution prevention an economic necessity. This innovation leads to the ultimate objective, the circular economy. It is a system designed to keep materials in use as long as possible. By relying on renewables and cutting losses, this model respects planetary boundaries, ensuring industrial growth doesn't cause ecological collapse. This offers a solution to the tragedy of the commons. Instead of inevitable depletion, we can focus on managing the commons, the idea that collective rules can successfully safeguard shared resources. Nobel laureate Elinor Ostrom demonstrated that ordinary communities can create sustainable management practices for shared environments that last for generations. Environmental stewardship is an integrative field. It requires policymakers, scientists, and engineers to collaborate on building systems that actually work. Sustainable development is an achievable reality, but it relies entirely on the next generation's expertise to engineer the systems and enforce the limits that will protect our future.